Okay, I am Dr. Babu, Department of Biomedical Engineering, Head of the Department of Biomedical Engineering, Sri Sanmuga College of Engineering and Technology, Salem. Okay, in this video, I am going to explain about the polarization in electrodes and polarized electrode and non-polarized electrode. That is types of polarization electrode. Okay. First, polarizable and non-polarizable electrode. Before going for the polarizable and non-polarizable electrode, first we have to know about the what is polarization in electrode. When an electrode is immersed in electrolyte, in interface there is a exchange of ions takes place. That is, from the metal electrode, some of the ions in the surface of the metal electrode is moving and going to the electrolyte, and in electrolyte some of the ions crossing the interface and going into the metal. Okay, in this case, after equilibrium at the interface of the metal electrolyte interface, that is joining surface, okay, one side we are having the ions, positive ions, and the another side we are having only the negative ions. That depends upon the type of the electrode. So this is called polarization. Okay, moving of the ions in one side, in the metal side, or one side in the electrolyte side. It may be positive ions or it may be negative ions. That is called polarization. So the polarization takes place in the electrode is called polarization in electrode. Okay, in this case depends upon the polarization properties. We are having polarizable electrode and non-polarizable electrode. What is polarizable electrode and what is non-polarized electrode? Okay, in this diagram you can see there is a perfectly polarized electrode, perfectly non-polarized electrode. So there are the two types of the electrode. Okay, what is perfectly polarized electrode is, these are electrodes in which no crosses of the electrode-electrolyte interface when a current is applied. The current across the interface is a displacement current and the electrode behaves like a capacitor. Example, platinum electrode. It is called noble metal. Platinum is considered as the noble metal. So what is this meaning is, in the electrode we are applying a small current in the electrode-electrolyte interface. When we are giving the current, there must be a disturbance in the equilibrium, that is polarization. Ions takes place in the metal side and the electrolyte side generally. But if there is no ions are moving through the interface because of the small current applied to the electrode-electrolyte interface, then it is called polarizable electrode. If the current is zero, that is no current is moving in the interference, no current across the interface, that is called perfectly polarized electrode. But in practical, some of the ions will be, a small quantity of ions will be moving in the electrode. So that is why it is called polarizable electrode. But the current is equal to zero current crosses the electrode-electrolyte interface. That is called perfectly polarizable electrode. So there is a symbol is capacitor. Okay, it is acting as a capacitor. That's why it is called capacitor. Okay, this kind of perfectly polarized electrode is generally it is not used for the recording purposes. Okay, it is offering the high resistance for moving from the skin to the electrode, and generally this kind of electrodes are used for the stimulation purposes. So that's why it is used for the stimulation purposes. perfectly polarizable electrode which is used as a stimulation purposes. Okay, next we can go for the perfectly non-polarized electrode. What is the meaning of perfectly non-polarized electrode? Okay, in this case, these are electrodes where current passes freely across the electrode-electrolyte interface when small current is applied to the interface, requiring no energy to make the transition. Okay, without any external energy, when small current is applied to the interface, okay, some ions will be moving across the interface. Okay, so the current passes freely across the electrode-electrolyte interface, which is called the perfectly non-polarizable electrode. Okay, very simply we can explain, if the ions are moving through the interface, then it is non-polarizable electrode. If there is no ions moving through the interface, it is polarized electrode. If zero ions are moving through the interface, that is called perfectly polarized electrode. So perfectly non-polarized electrode is if no number of ions are freely moving through the interface, it is called perfectly non-polarized electrode. So this perfectly non-polarized electrode which is used for the recording purposes. So for biosignal measurement, for biosignal recording, we are using the perfectly non-polarizable electrode. Example for the perfectly non-polarizable electrode is AgCl electrode, silver chloride electrode. And the example for the perfectly polarized electrode is platinum electrode. Okay, very simply, perfectly polarized electrode is used for the stimulation purposes, and the perfectly non-polarized electrode is used for the recording the biosignals. So this is the polarization in electrode, polarizable and non-polarizable electrode. What is perfectly polarized electrode and what is perfectly non-polarized electrode? Okay, polarizable and non-polarizable electrode in continuation. No electrode is perfectly polarizable or non-polarizable. Theoretically, we can say perfectly polarizable electrode and perfectly non-polarized electrode. But practically, no electrode is perfectly polarizable or perfectly non-polarizable. Platinum electrodes are a reasonable approximation of perfectly polarizable electrode. Okay, they exhibit Vp that primarily results from Vc and Va. Used for stimulation, this is used for the stimulation purposes and for higher frequency biopotential measurement. Okay, perfectly non-polarizable, perfectly polarizable electrode, generally it is used for stimulation purposes, and high frequency biopotential measurements also it is used. Then we can come for the AgCl electrode, silver chloride electrode. It behaves reasonably closely to perfectly non-polarizable electrode. Okay, so AgCl electrode behaves and very closely to the perfectly non-polarized electrode. There is a movement of the ions in the interface. Okay, they exhibit Vp, that is plate potential, that primarily results from Vr only. Okay, used for biopotential recordings that range from high frequency to low frequency. Okay, so this is once again I am telling, polarizable, perfectly polarizable electrode is for stimulation and the perfectly non-polarizable electrode is used for the recording the biopotentials. Okay, the symbol for perfectly polarizable electrode is a capacitor and the symbol for perfectly non-polarizable electrode is a resistor. Okay, in this slide we can explain about the silver chloride electrode, that is perfectly non-polarized electrode. Okay, AgCl is a practical electrode. Silver chloride electrode is a practical electrode that approaches the characteristics of a perfectly non-polarizable electrode. It can be easily fabricated in the laboratory. This diagram explains about the how we can fabricate the silver chloride electrode. Okay, so one side we are having the silver is immersed, and another side we are having the silver is immersed in the potassium chloride solution. Okay, so the potassium chloride solution is separated as a ionization, that is potassium K plus ions and the chloride minus ions. So one electrode is connected as positive and another electrode is connected as negative potential, so that the potential K plus is moving towards the electrode which is given negative potential, and the chloride minus which is moved towards the electrode which is given to the positive potential, so that the chloride will be deposited on the silver rod. So it is AgCl electrode. So it consists of a metal coated with a layer of a slightly soluble ionic compound of that metal with a suitable anion. Whole structure is immersed in an electrolyte containing the anion in relatively high concentration. Okay, electrolytic process. The process is called electrolysis. And the electrolytic process, how we can fabricate the AgCl electrode fabrication. In this diagram you can see this. One side we are having the Ag electrode to be chlorided, and another side we are having the Ag electrode is acting as the cathode. One is acting as the anode and another is acting as the cathode. Battery of 1.5 potential is applied to the two Ag electrode. One is acting as the anion and another one is acting as the cation. This okay. An electrochemical cell with the Ag electrode, silver electrode, on which the AgCl layer is to be deposited, serves as anode, and another piece of Ag having a surface area much greater than that of the anode serves as the cathode. Here the left side we are having the anode which is connected to positive, the right side we are having the cathode which is connected to the negative. It is immersed in the sodium chloride or hydrogen chloride solution. Okay, the reactions begin to occur as soon as the battery is connected, and the current jumps to its maximum value. As thickness of the deposited AgCl layer increases, the rate of reaction decreases and the current drops. Initially, the chloride will be deposited on the silver electrode. After that, if the thickness is increases, amount of current flowing through the circuit will be gradually decreases. This situation continues and the current approaches zero asymptotically. This is finally we are getting the AgCl. The Cl chloride ions will deposited on the silver electrode, so that it forms the AgCl electrode. So in this lesson we have studied about the polarisable electrode and the non-polarisable electrode. Thank you.